Hello, thank you for your participation. I still really appreciate the time you took for our first round of interviews. That was super helpful. I would now like to ask you to watch this video as a preparation for a brief conversation about the method that's been developed in the meantime. It's been a while since the interviews, and by now I've almost completed my PhD, and I want to share with you the developed approach, or we might also call it workflow, and I would like to ask you for your feedback. Back in the days, we have referred to the core of the topic as COPD, the quality of preliminary design information. In the meantime, we have found out that maturity is probably an easier and a better term to describe what we mean. We mean how a piece of design information, it might be a CAD file, it might be a document, it might be a parameter value, is going to evolve. And we think this evolving is similar to a fruit ripening on a tree. So it's similar to maturity. So the term COPD was simply replaced with maturity. You might remember this visualization. We used it back in the days to show the branching of the COPD project, or the maturity of the individual aspects and how they are related. A bit of a roadmap, similar to a subway map. And we have one branch where we have the COPD for the design information itself, and the other branch, which is the COPD for the task needs. And we wanted to assess and find out what in the situation itself, what kind of information is available, what the task needs, match them, and based on that, we wanted to provide you with advice about what task to select, what effort to allocate, all in order not to waste efforts. The idea was based on that you wouldn't want to put all the effort of an FEA, a CFD, whatever is used in your industry, on something, on an idea that is just a back of the napkin sketch. Now, over the course of my PhD, we have gained a substantially deeper understanding of the different ways and aspects how information can be immature and how to express that maturity of design information. There are so many related adjacent fields. So we decided to adjust the scope of the research a bit and to drill down to be ultimately able to really comprehensively and holistically understand and capture in what ways can design information be preliminary. During the interview study, we talked about relevant terminology. I used a toy car example, and I often use the terms precision and ambiguity to differentiate and to show the both ends of the spectrum. And those were used to see how something can be preliminary. To provide an overview of the developed method or workflow, let's have a look at this overview. Firstly, we have achieved one hierarchical structure of aspects how a piece of design information can be preliminary or immature. This is shown by this taxonomy. I will go into detail later on. For now, let's just take the taxonomy as a theoretical foundation. The goal has always been to use our findings in practice or to develop something for you, the practitioners. So a lot of thought has been put into the taxonomy. It might be used similarly to a dictionary while you're talking about maturity. But are there other ways you can benefit from this research? I believe so. Let's have another look at the new roadmap. The idea is to let you assess the maturity of the parts you're designing. With some processing, this can be used for two main applications. To provide direct or normative advice, in the sense of if X, then do Y, the upper branch, or to provide support mainly by visualizing the maturity information, the lower branch. I just mentioned the assessing of the maturity. If we try to do this only based on the taxonomy, this is not such an easy task. So we develop what we call eliciting schemes. I will talk you through these in detail in just a moment, but let's just think of these as guides and a scale. Initially just based on the red, yellow, and green traffic light colors that the maturity can be assessed against. As each of these 17 subfacets, but not facets or perspectives, are assessed, this leads to 17 values. These are not so easy to handle or get an overview of. Therefore, we developed several alternative aggregation schemes. Which one to apply depends on the circumstances. By using one of these schemes, we condense the 17 subfacet assessments into one maturity value for the piece of design information we're looking at. We can then use that aggregated value for either of the two branches that we've seen in the overview figure. I will only briefly touch upon the upper branch. The idea is that the generated information, enhanced with some other information about the design process's structure, given by design structure metrics for those who really want to go into detail, as well as the maturity values, both are fed into a logic tree, and based on that, what we call normative advice, in the sense of if X, do Y, can be deducted. This is more of a long-term goal, and the other approach seems more intuitive and usable as a quick win. So let's have a look at it. The information is mainly centered around visualization. We chose augmented reality, and I will soon show a video of how the related app looks. Okay, after this overview, let's dive into the details. First stop, details of the taxonomy. Firstly, maturity is decomposed into three big perspectives. That is, content, about the information itself. For example, how complete it is. That is, context, for example, how well it meshes with adjacent parts. And that is provenance. As we realized, it is vital for an assessment of the information that I have produced and that I'm currently assessing to know what went into it. Rubbish in, rubbish out. That's the idea. On the next level, we have 6 facets accounting for how complete is the information. How clear is it? So how easy is it for someone else to understand? How consistent is it within itself and with neighboring parts? We have dynamism, which is about the expected changes of the information and the overall goal. Prerequisites are how the inputs were used. Process, finally, is about the methods I used to create the information. The first subfacet of the facet completeness, coverage, is asking if all aspects are covered, such as, are there all chapters in the document that I'm writing? Or are there all sub-assemblies in the CAD file I'm creating? Next, depth is about how worked out these aspects are. Are these chapters fully fine-tuned or just bullet point lists, or even not there at all? Are these placeholders, or did I already do a lot of testing and fine-tuning on the CAD parts? Procedural completeness, as the last of the completeness subfacets, is about the formal or maybe even informal sign-off, stage gates, etc. play a role for this. Clarity's first subfacet is nomenclature. This is concerned with sticking to definitions, using the same units, putting the right symbols, etc. Conciseness, or as the small visualization shows it, the lack of waffle, is about my efforts to briefly summarize the important points in a document, so I might remove repetitive chapters or summarize these. I might hide distracting details such as surroundings in CAD files. The goal of vagueness is to think about if the information leaves room for interpretation or not. Therefore, we chose the visualization of the base or the faces. Consistency's first subfacet is compatibility. This is about how well the information meshes with its surroundings. Does my CAD file properly connect to its surroundings, or have the interfaces changed? Coherence is a similar view, but on the information in itself. Do sub-assemblies mesh? Do chapters in a report hang well together or not? Ambiguity is often used interchangeably with vagueness, not in our interpretation. As a recap, vagueness was about the room for interpretation. Ambiguity is about the overall problem framing and if a mental model exists. Think of it If you know exactly what to do to tackle the problem, just like ticking off a mental checklist, or if you have to find out what variables are needed and how their relationship is. The first subfacet of dynamism, change extent, is about the amplitude, or how much the information is expected to change, whereas stability is about how often changes are expected to happen. The need to include predictability was detected while we were struggling with the explanation of some ups and downs in our self-assessment when we tried to apply the method to our own work. So predictability is about how well the goal is known, and based on that, how well the problem to be solved is known. Prerequisites is about where the information stems from. Availability asks, did I have to make assumptions? Traceability is about, can I find out where the information stems from? And ultimately, credibility is about how trustworthy my inputs are. The last facet of the taxonomy, process, is about the process I use to generate the information. It is decomposed into rigor, that is about how intensely I applied the method, whereas suitability relates the chosen method to the information that was available at the time. To clarify, in the situation I might ask, should I really use that highly sophisticated resource and time-intense method, such as an FEA, based on this back-of-the-napkin sketch? Before we jump right into the details of the eliciting schemes, let's have a brief recap. The aim of the eliciting schemes is to support you as the practitioners in applying the theoretic taxonomy in real life. So these schemes are designed to help you with the assessment. Let's have a look at them. So the 17 subfacets form the rows of the eliciting schemes. As we have to assess something, we need a scale. The scale is based on the 3 traffic light colors and 2 in-between categories. The decision to start at 0 will make more sense once we had a look at the aggregation mechanisms, and we will get into that soon. So we have the 17 subfacets as rows and the 5 possible values, that is 0 to 4, as the columns. It might still be not easy to decide which of these values to allocate in a specific situation. To help you with that, we have included textual descriptions. But not only for the generic taxonomy, no, these descriptions are tailored to the 3 types of design information that I already mentioned. There was the parameter value, the document, and the CAD file. So for each of these types, the textual descriptions are adjusted, and mainly for the parameter value, some of the more abstract or complex subfacet assessments do not apply. So if we ask you for an assessment on this 0 to 4 scale, 0 means there is almost nothing. Maybe you have already some experience, and that means you will start with a 1 or a 2. And then we have 4 on the other end, which means that everything is perfect. But wait. How do we choose one of these categories? Well, there are several levels of sophistication and IT support. We started out with a pen and paper circling assessment, but this can also be done digitally, or in the long run, this might be directly entered into a form or even a PLM system in case you use one. No matter which technical solution we use, we perform 17 of these assessments, 1 for each subfacet. Let's have a look at an example. Let's assess the method suitability for a document. Let's assume we're at the final stages of a huge design report and we want to reformat the headings. If we use predefined headings in our word processor, this is a matter of a couple of clicks. Whereas if we increase the font size, apply the bold font face, etc. to every single heading by hand, this can be a quite tedious task that wouldn't be suitable for this situation. Assigning a 4 out of 4 for the pre-formatted headings would be advisable, maybe 1 out of 4 for the manual heading adjustment. So let's circle this one. Or let's take another example. We want to assess the depth of a CAD file. If we have just some CAD parts that we downloaded from the internet or that we copied from another related project, we should put a low value for depth. It looks fine-tuned, but that's just how it looks and not how mature the CAD file really is. Okay, that's how the eliciting schemes work. The result are 17 values. These might be way too many to provide an intuitive overview. We have to make these more usable. And this is part of the next step, the aggregation schemes. Okay, so now we want to aggregate the results of the 17 subfacet assessments to get a better understanding of what the maturity of our CAD file is, or to report this value to someone else, or to use it for one of the use cases that I will talk about soon, or even for other ones that I won't refer to. I won't go into detail, but let's say we have two different mechanisms to aggregate such values. We have the compensating mechanism. Think of the example of a simple average, meaning if the coverage is really perfect, so a 4 out of 4, but the depth is really poor, so a 0, one could say, okay, we average these and assign a 2. But this example already shows that the compensating aggregation might hide important detail. We have several placeholders in our CAD file or just the basic structure linked to several empty part files, but these have no content at all, so their depth is 0. If we say, well, the average is 2 out of 4, this hides the fact that this is just the structure and no real design yet. The other algorithm we can use is the non-compensating one. There are different mathematical operations you can use. You can norm the assessment results on a 0 to 1 scale, and you can multiply these, or you can use the min operator, etc. So while the details exceed the content of this overview, the non-compensating aggregation has the benefit that if something has been assessed really poorly, for example, a 0, this will propagate. It will climb up the taxonomy tree. But this advantage at the same time is a disadvantage, meaning the overview of the other assessment results or the overall maturity might be rendered 0 just by one subfacet being 0. So, due to the different advantages and disadvantages of the compensating and non-compensating aggregation mechanisms, we carefully considered alternative schemes based on both. Here we can see the theory-based one and the sequence in which compensatingly and non-compensatingly the values are aggregated. All this should lead us to a quite meaningful aggregation of the subfacets into one value for maturity for the one part we are assessing. Okay, let's talk about the use cases that I already mentioned. In the overview figure, we can see these two branches. Here, I will only briefly touch upon the normative part. It is quite theory-based. The goal is to provide hard fact advice in the sense of if the maturity and other needed inputs about the structure of the design process that I won't discuss in detail for now, but if these indicate that you are, based on your design information, at status X, then do Y. While this might show potential in the future, there are some drawbacks, such as that you need to have some very detailed knowledge. So let's focus on the other branch, the informative advice. Informative advice, that might sound like a contradiction, but the idea is you still get some advice about what to do. But this advice is only provided to you in part. The other part has to be provided by you, your gut feeling, your expert knowledge, your experience. The informative advice is mainly about visualizing the maturity. We chose augmented reality for that. A lot of thought went into that. But based on the empirical work and a publication reporting what they term a mule concept, where an outdated product version is part by part replaced by the newer version, that all leads us to assume that you have, or maybe you can rapid prototype, etc., a physical version that can be overlaid with augmented reality. I will soon show you a video of how our AR app works. But firstly, let me provide you with a brief recap. We have the theoretic structure given by the taxonomy. You, as the practitioners, have assessed, you have elicited situation-specific values for the part you're designing, leading to 17 values on a scale of 0 to 4. We have aggregated those values into one metric, maturity. If this is not only done by you, but by all participating designers, you can see in the upcoming video how parts are traffic light schemed colored, and that gives you the impression of how far evolved or how mature parts that are next to your design or somewhere else. Let's have a look at the video.
As the app is started, guidance to an initial pose is provided. CAD files are downloaded. Based on their maturity, traffic light colors are overlaid. Let's flip it over to get a better view. An additional overlay is toggled, and a table showing the priority scores computed as per our method is shown.
So we have seen the race car. If you imagine you are designing the aerodynamic part on the side, which is shown as red, and that you want to bolt it to the roll bar, which is green, you can go ahead. For the connection to the main body, which is shown as yellow, you should either wait or talk to the expert in charge or do more research. This is also a form of advice, but not this hard fact-based if X do Y. You get an impression of surrounding parts' maturity statuses, and you can decide what steps to take based on that. The table that was shown in the video also included the priority score based on the normative branch that I only mentioned briefly. So that's it. That's the summary of the overall topic. I know it's quite a lot to take in at one time. So that's why we pre-recorded this video and sent it out beforehand. Now you can take your time and process our findings. If you have any urgent questions, please feel free to get in touch with me. Otherwise, thanks again for the time you took to watch this video, and thanks for the time for our upcoming talk, which is based on the questions I included in my last email. To summarize what I want to talk about, based on the overview that I've given you in this video, and which is about the project and how my PhD evolved and the concept demonstrator, I would like to assess how you feel about it. What are the pros? What are the cons? What are your impressions? Thanks again for all your time, and I'm really looking forward to our upcoming virtual face-to-face conversation. Thank you.